So our first chapter is about solar energy. So solar energy, as we know, the energy that is obtained from sun. First thing, why solar energy? Because solar energy is the most abundantly available form of energy. There is not a single day when the sun is not rising. Is or no? And sun is free. Sun is free for everybody, for everyone and everywhere. The sun can never be privatized. Sun can never be privatized. Is it possible to privatize the sun? No. So sun is free. The first thing is that sun is free. Wind is also free. But as our topic is about solar energy, we will concentrate now on solar energy. So solar energy is an important, clean, cheap and abundantly available energy. Clear? What is the next point? The solar irradiation from the sun that is converted into thermal or electrical energy using solar cell is known as solar energy. The sun is emitting some solar irradiations. So these solar irradiations are collected, are received on a solar cell or a solar panel, which somewhat looks like this. And this solar panel converts the solar irradiations into thermal energy or electrical energy. So that conversion is called solar energy, and it is a clean form of energy because there are no pollutants associated with harnessing the solar energy from the sun. So it is also known as green energy as it doesn't cause any pollution. Okay? So solar energy is cheap, solar energy is free, solar energy is available abundantly, and solar energy is a clean form of energy, or we can say solar energy is a green energy. And now our country, India, is working greatly upon this integration of the solar into the existing power systems. We have several schemes of the government where installation of solar panels in rural or urban areas is what we can say is enhanced over the past few years. We have a lot of schemes. One of the most popular schemes is that PM Surya Ghar Yojana. You know it, right? PM Surya Ghar, where government is giving some sort of discounts, some heavy discounts. Okay, upon installation of solar panels or solar systems on the rooftop. So accordingly, previously there are some other schemes also, but currently this PM Surya Ghar is more popular. Okay. So next, what are the units of solar power and solar energy? The solar energy, since it is a form of energy itself, so it is measured in joules. Clear? So solar energy, when it is calculated commercially, it is usually expressed as kilojoule per meter square per day. How much kilojoule of solar energy is incident on a particular area for a day or for hours? It is also calculated on monthly or yearly basis. So these are all commercial calculations. And when we come to solar power or the solar irradiations, these are expressed in terms of watt per meter square or kilowatt per meter square. So solar energy is having the unit of energy itself, that is joule, and solar power is having the energy of power itself, that is watt. Okay, so next we have a very important topic, that is photovoltaic cell or the solar cell. So what is a solar cell? It is the basic structure that is responsible for conversion of solar energy into electrical energy. Okay. So the photovoltaic cell is the semiconductor device that converts light into electrical energy. So whatever solar energy we are receiving directly from the sun, that is in the form of light only. Okay. So that light or that solar irradiations are incident on a solar cell or a photovoltaic cell. So this photovoltaic cell is a semiconductor device. This thing you need to understand. It is made up of semiconductors. The voltage induced by the PV cell depends upon the intensity of light incident on it. So whatever the voltage that a solar cell or a photovoltaic cell will produce, it will depend on what amount or what intensity of light is incident on the PV cell. Okay, it is directly proportional. Higher the intensity of light, higher will be the solar higher will be the voltage produced by the cell. So this name photovoltaic itself depicts that photo means light and voltaic means it produces voltage or the capability to produce voltage. So this name photovoltaic is given to the solar cells because they have a capacity to produce voltage from light. Okay, actually this photo is taken from photons. What are these photons? Photons are the energy particles, or you can say the energy carriers in light are known as photons. So the energy from these photons are utilized by the semiconductor material to produce the voltage in solar cell, or you can say photovoltaic cell. So the materials that are used most popularly for this, so the materials that are most popularly used for production or for the manufacture of the PV cells are arsenide, indium, cadmium, silicon, selenium, gallium. So these are some materials which are used for manufacture of solar cells or photovoltaic cells. So out of all these materials, this is silicon and selenium. The silicon and selenium are most popularly used due to their wide availability and also the economical factor. Okay, so this is about the materials that are used in solar cells. So here this diagram actually depicts how the voltage is produced in a solar cell. So let's discuss this diagram. So the light that is incident on the solar cell, that may pass through the solar cell or it may be reflected through it. So as you can see the structure, see, as we said, it is a semiconductor device. So there is a N-type silicon material, there is a P-type silicon material. and this N-type material contains, this N-type silicon material is having a hole concentration, and a P-type material, N-type material is having some concentration of electrons, P-type is having some concentration of holes. Also, in addition to electrons, it is also having some holes, and this N-type, it is having both electrons and holes. So what is happening? So the light that is incident on the semiconductor material, that can be either passed through it or it can be reflected. So there is an anti-reflection coating that is basically made up of glass, which is provided on the solar cells, and accordingly there are two electrodes. These electrodes are basically nickel, made up of nickel material. One is acting as a positive electrode, another is acting as a negative electrode. So the semiconductor materials, these materials are neither conductors, these are neither insulators. So they have a completely different property than these conductors and insulators. So this property itself of the semiconductor helps to convert the light energy into electrical energy. So when the semiconductor material absorbs the light, the semiconductor material, it has the property to emit some electrons. So previously, the electrons were confined to the structure of the semiconductor. Now, how they are getting emitted? The electrons are getting the energy from the light or from the energy particles that are called photons, which are available in the light. So when the electrons absorb the photons, they become energized and they start motion. Okay, and whenever there is a motion of the electrons, there is a current. Is or no? So there is a current whenever there is a motion of electrons. So basically, we can summarize that the light energy that is incident on the solar cell or the PV cell, the light energy itself contains some energy in the form of photons. So these photons, when strike on the surface of the semiconductor material, the energy of the photons is transmitted to the electrons which are there inside the semiconductor materials. These electrons inside the semiconductor materials, after gaining some energy from the photons, they become energized and they start moving or they start motion. So whenever there is a motion of the electrons, there is a current. So in this process, the photovoltaic cell produces a current. Okay? So in the next class, we will discuss some details about these PV cells. What are PV cells? What are photovoltaic arrays? What are the applications of photovoltaics? And also we will move on to the topic that is concentrated solar plants. So thank you, and we will meet you in the next class. Thank you.